Good morning, everybody.
Good morning, Andreas.
Good morning.
So, welcome to our early bird exchange. Today in our tech session, we have Martin Werner on stage, and he will present more or less all the features and benefits of the Fortinet EDR. So, Martin, welcome, and stage is yours.
Thank you. Thank you. Good morning also from my side. Unfortunately, I can't show you all the features and benefits of EDR. Otherwise, it would be a late night session. Arrow late night, maybe. We should rename it then. But I'll give you a short overview on PowerPoint, what we're talking about, what is the difference, especially to EPP, what we saw last time from me. And then we go into a demo, which you see then the product and the dashboard and all the stuff, and go a little bit deep dive to see what we're talking about, what's the idea behind EDR is. So you see here, a short recap of EPP, then a little more, bit more deep dive into EDR, and then as mentioned before, we go to the demo, so you see the product live and in color. And let's go in. What is EPP? So we had it last week. Last early session, is the classical endpoint protection platform, which means, as you could see, it was in the really early stages, was the real antivirus, signature-based, and all this kind of stuff, with some limitations behind. And then we see later why we switched, or the industry switched then to EDR. But it's still existing. We had a lot of customers out there that still have EPP with some reasons behind. So there is not a must to change to EDR. It has some benefits, of course, but it's just give you a little bit a reminder and that you are sure where the difference are. If you check that in the FortiClient world, you can see here we have on the EPP part on the FortiClient, we have the application firewall and the anti-malware part. And of course, our FortiClient has more the focus to fabric integration, which means support for CTNA, the support for VPN, vulnerability management stuff, and of course the integration into the FortiGate, which means into the FortiFabric, with all these funny features here, which we have mostly also on the EDR side. See here from a licensing point of view, what is the difference before we then switch to EDR, but you just have this reminder. So what is EDR? And then as you could see here, EDR is endpoint detection and response. And if you remember the naming EPP, Endpoint Protection Platform. So the idea behind EDR was in the really early stages, just the detection part, not the prevention part, or not the protection part, and just the detection part. And that's why you see sometimes it was really in early days called as flight recorders. And behind it here was we took all the logs, so all the things that happens on the client, and sent it to a central management console or central database. There was in the beginning some really limited, not artificial intelligence, but more machine learning or signatures behind or whatever, just to see or to figure out if something happened bad on the client. But the focus was really one for the SOC team, for the forensic guys, to go into the console and check what's going on with the machine and searching for something which is malicious or suspicious, or searching for something which is not normal on my environment, just to get all the information what's going on my endpoints. And as you could see in the middle, more and more than with the time, all the vendors start to combine the EPP agent they already had together with the EDR agent. There are still some vendors out there that still have only, let me say, an EDR agent. We at Fortinet today has also the FortiClient, which is more or less an EPP agent, and the EDR agent, but we also plan to bring these two together. But this is nothing which will happen this year, maybe during next year, but I'm not sure about that, but we're planning to bring this all together. And as you could see also, it was really used in the beginning for IOC hunting, for indicator compromise. So this gives you the capability to search for hash keys, IP addresses, file name, what else, whatever. And if you read all that, and then maybe it comes to your mind, okay, that means somebody has to take care about this console, somebody has to log in, somebody has to take some time to check some things, to search. And that's why the vendor starting also to offer MDR, which means it's just a managed detection response. So this means all this IOC hunting, to go out checking what's going on the clients. Is there something suspicious or something malicious? What we're doing from the vendor, in our case from our guys at FortiGuard, and we take all these time-consuming parts for you, and we send them out and report to you, which we say, hey, this and this we saw on the client, which or what happened, which is maybe not so good, which you said should take care about, or as well, we got an immediately response from us if we saw something really malicious, which means then you got a call from us and the people told you, hey, you are under attack, you have to do that and that and this and this. Important to know, no one, not nobody, but we as Fortinet, we don't make the doing on your side. We just check the logs and we give you the information what's going on, but the doing you have to do the customer, or you as a partner have to do that for the customer. So what is our EDR design principle? So we have combined as well, let me say, some parts from the EPP world and the EDR world. First is we have a unified agent. There's one agent looks the same for Mac, Linux, and or Windows. There is a strong, let me say, machine learning and behavior-based protection behind, so that a lot of things will be detected without some integration from somebody, from an admin or whatever. You see the support for legacy OS, so we can support down to Windows XP with respect 3, lightweight agent, of course. And as you could see on the right side of the picture, the idea is that we have a pre-infection fault, which is, let me say, more or less the classical antivirus part, so that our system is able to detect a well-known malicious code based on, let me say, signature, or based on machine learning, or based on behavior-based detection, so that you don't have to take care about this stuff, which is, let me say, common. So the system can block that for you before it happens something on the machine. And then the other part is the post-infection part. So we all know there is no 100% detection out there. So, but what we also are able to see is if the machine is hit by malicious code, the malicious code is running, and then normally something happens. Of course, sometimes, or mostly, there's the machine will be encrypted, which we are able to detect and to block, or there will be a data leakage, so they try to stolen your data. And we will see this as well, which means we see that some strange processes are running. There are copying data or sending data out of your company, the classical connection to a command and control server, which we are able to see. So we are not only based on the part, let me say, the protection part or detection part, we are also strongly based on the post-infection part. And so we are not only rely on that the system will detect what it is before it happens. We're also able to see, is this malicious or suspicious also after infection, and we can block them these attacks as well. Here, the proactive attack surface reduction, which is nothing else than a vulnerability management. So we see all the installed software on the clients, and we check that against known vulnerabilities regarding CVE databases, and show you that, okay, in your environment, you have this and this clients with this and this software, which has this and this and this and this vulnerabilities. And then you can, based on that information, you can create policies, which means, as an example, okay, don't allow any vulnerability which has a critical state. Block this automatically. This is then what we're calling a virtual patching. So the application maybe could be run, but the vulnerable part will be blocked. And that's of course reduced heavily the attack surface. So because a lot of attacks we saw out there are trying or using known vulnerabilities in some applications, and then you can close these vulnerabilities with this technology, which doesn't mean you don't never have to patch your system. This is just gives you a longer time frame to react on this and then to test the patch and then to roll out the patch. But for some short times, you can close this vulnerability with this virtual patching, but we strongly recommend that you patch your system after the patch is available. Next is the prevention part, which is the real-time prevention part based on combination on machine learning, next-gen AV, and all this kind of stuff. Also the sandbox integration, which means if a file hits the machine, which we never saw before, means as well our FortiGuard cloud. So if a file hits the machine, we check locally the hash key, the name, from where is it, and all this stuff. If we don't see a result, we send the hash key and the name and the size and this kind of information to our FortiGuard cloud. If you also never saw this file before there, then you are able to say, okay, send it to the sandbox for destination and give me the result back then, if it's good or if it's bad. If it's bad, of course, the information will get to the EDR client and then you can block it. Behavior-based also means that we check in real time around 1200 points of the operation system. So that means we check what is the processor doing, which resources he needs, which resources he contacts. As an example, he writing in some registry entries, he reading from some registry entries, and so on. And based on all this information, the system can then define and say, okay, that's really looks like a malicious behavior. I never saw this file before, but what this file is doing, what the process is doing, looks really malicious, and I blocked it. And a simple example is you download an executable from an, let me say, unknown website, which is not rated, as an example. The executable on the machine is we never saw before, no idea what it is. You start it, process starts, the process open an internet connection, connects to an unknown IP address and starts downloading software. These are things which heavily looks like it must be an malicious code, and then the system will block that without any information about the file or about the process itself. And the detection and containment, we mentioned before, this is what we say if there are some data exfiltration or lateral movement, and we are able then to block this communication. We are able to deny the file system access and those things. Of course, a heavily part of that is the ransomware protection as well. So that we see that an unknown process is touching a lot of files in short time and changing the name as an example. That looks for us then like an ransomware attack, and we're also able to block that without the information of the file. Of course, behind of that, there is an automatic backup approach. That means we are able to back up the files when the process is touching them. And if we come to the conclusion it must be in ransomware, we delete the process, we stop the process, and then we restore the files. So you have the files in an, let me say, unencrypted state and back. This is, of course, not based on the VSS from Microsoft, Virtual Shadow Copying Service, but because most attackers will shut down this service to prevent that the system is able to make a backup before their encrypted files, of course. The automated response framework. Of course, you have some things which happens on the machines. If you have a bigger environment, let's say on a daily basis, some detection of a malicious code, download of some malicious code, and so on and so on. And of course, you don't like to invest time for every of these simple cases. So you can create an automated response remediation which means based on playbooks, you could say, hey, if happening this and this and that on the machine, put in as an example into a quarantine network, or isolate the machine, or let run this and this script, or do this or do that. So you can a lot of stuff which normally takes a lot of time from you automate. So you don't have to take care about every malicious code which is found in the environment, especially the well-known malicious code, which really say, okay, it's not necessary for me that I spend time there, or somebody from the support organization. So just like run the script as an example, or put them into a remediation, and so on. Good question is why EDR? At the beginning, it was the answer to APT, Advanced Persistent Threats. Maybe you remember that was on, like today, the ransomware was in the past was as APTs. That was really hard to detect for these classical EPP solutions. Mostly nearly impossible to detect. Even there was a lot of target attacks in the older days. Then we had the living of the land attacks, which means fileless attacks. As an example there, you were browsing the web. There's a vulnerability in your web browser. You hit, let's say, a good website, which was infected by an intruder. They've checked, oh, you're coming with a browser which has this and this vulnerability, and they send you through this vulnerability some malicious code directly into the memory of the system. So there was no need to install a file before, or an executable or whatever. And they just let run the malicious code inside of the memory, and maybe started normally then to PowerShell or command line or whatever, and going from there to infect the machine. And that was impossible to detect for, let me say, the classical AV. It looks a little bit different today, but in the beginning it was impossible to detect that. Next one was the target ransomware attack, the big hunting gaming, which was also really specialized ransomware attacks against the targets, goes hand in hand with the target attacks. Then also the IOC hunting was a huge part, just to figure out what is going on in my environment. Is the client infected? Is there some more clients infected? And at least, of course, lack of visibility, which is something which has, even today, more or less every customer to fight with, which didn't have an EDR solution, which still rely on EPP as an example, has this lack of visibility. I hear a lot from customers, if they got an infection of one client, the first questions they had is, oh, is this the only client? Or there are more clients in my environment which are infected, or has this code on the machine maybe already running, how to figure out. And then we see a little bit later in the demo, this is relatively easy to figure out with an EDR solution, which of my clients maybe are infected or affected by an attack or not. So just give you a little bit an idea what's going on with an EDR. You see here the let me say target attack, and we are able with the EDR to see the suspicious behavior. We can show you the unknown software on the client. So that means if you go to the console and then you maybe see, hey, what kind of software is that? This is not a software out of our repository, something we never saw before. We take care about it. We are able to show you the lateral movement, and of course we are also able to show you an unusual data exfiltration, which is, let me say, an important part. So this means we don't only rely on the detection or protection part. Even if we're missing that, we are able to detect something going on the machine, which is bad, by checking what kind of data are exfiltrated. Is this completely unusual, or is this goes to a well-known, let me say, bad IP address or whatever? So we all can see everything what's going on in the machine, and can the system can then decide, not only based on the beginning or even on the end, can decide, oh, okay, that looks malicious or suspicious, and are able to inform you what to block it. The other one is this fileless attack. As well, we see the suspicious behavior, but, and this is, let me say, one of the most important parts for fileless attack, is we are able to see or to record the commands used in PowerShell or even in the command line. So which means the malicious code runs on the memory, opens the PowerShell, starts to set up some commands. We are able to see that, and at least we can store that and can show you that in the console. Of course, we also have some techniques inside to detect to check this code and to decide if it's good or if it's bad or is it suspicious, to give you more protection against this kind of attacks, which are still alive, by the way, and we see a lot, by the way, still. Of course, we have some integration in our existing Fortinet world, especially into the FortiGate, which allows you then to send you some tasks or commands to the FortiGate. Not only the telemetry sharing, also the automatic blocking of malicious IP, or to send this client into a quarantine VLAN, and so on and so on. We have an integration with Mac, of course, with our sandbox. You can send this, the logs into the analyzer or the SIEM. An integration with FortiSOA, which you can extend then these playbooks or workflow automatization. And we have an integration for the client, which you can check the posture check for the CTNA part. But we know we are not alone in this world. So you see on the right side, we have also integration into Palo, Checkpoint, Active Directory, and other vendors and other apps that you can share some data with. The MDR part, if the customer is not able to spend a lot of time into the system, you can outsource that to us, or maybe to you as a partner. You can do that as well if you like, or offer that. But the focus is for the threat detection and hunting and analyzers, notification and reporting, escalation request if it's needed, and of course also the remediation part of the system. So that means a copy of all the logs, what's going on the client, also all the information the client sends to the EDR console goes a copy to us, to the FortiGuard. Our guys are looking at that and can decide, okay, that looks suspicious or that is malicious, and give you then the information back on the reporting, or giving you a call and saying, hey, then you have an issue, you should react on that and that. And of course, we send some let me say, ideas what you could do and what you should do on the system and to secure that. You see, we have a global center, of course, or a global service for that. So following in Sun. So if a customer decides to go with that, he has 365, 24/7 support from us. Our guys are looking on the data for the whole day and are able also to inform you in the middle of the night or whatever, or whenever. So you are sure somebody take care about the data and can inform you if something happens on the machine which shouldn't happen. So let's dig into the demo. Let me stop that for a second. Check on it. Yep. You should see now the dashboard of EDR, right?
Yes.
You. Bigger? Too big?
I have a big screen. It's okay. It's okay. Thanks.
Okay for me as well.
So this is the dashboard. What you see if you log in, it gives you, of course, in a one-page view, the overview what's going on. You see, we have some inconclusive messages, which means the system's not 100% sure or has not finished the investigation about this file. We have 21 which are malicious. We have 15 unsigned vendors here, so that means there are some software from unsigned vendors. We have clients with 7 critical vulnerabilities. You see how many collectors are running, and so on, to just give you a really short overview what's going on. And then let me start from the right side, from the administration part, which gives you the information about your system, how many licenses, which kind of licenses you have, what is the version of your collectors. You can update your collectors here. You see the users. Those other users have access to the console here. You see the distribution list where you can send the information or the notification. You can export the settings here. You have the tools, especially maybe here's the IoT device discovery. You can enable that, and then one client of you can define here is able to detect what kind of IoT devices you have in your environment. IoT devices means IP cams, I don't know, oven, coffee machines today, whatever. You see maybe there are some devices which you don't like to have, you don't allow or whatever. You see the system events here, the IP sets and the integrations you can define here. We have the integration to sandbox, or you can integrate with the firewall, extended for XDR, identity management, and so on and so on. Next part then here is the inventory. You see your collectors. Your collectors are nothing else than your devices. Also, so devices where the client are installed on it. You see here, as an example, we had CentOS, which is running. We have a Windows 10 client, we have a Windows 11 client, which is disconnected, was online yesterday. The CentOS is running, as an example. And you can also go highlight that or activate that, and then you're able to say here, isolate this device, enable it, as an example, the EDR client, or disable it, or uninstall the whole client. If you want to change the system or whatever. So you can do some actions also already from here. Of course, you can group that. You see here we have a high security collector group, default. One of my colleagues here, then we have here Linux clients. You can create your groups as ever you like. And based on this group, you can create different policies with different settings. You see here your IoT devices. You have here the system components, which is more of the system itself. And you have here, let me say, the classical settings, how the system should react. So on the security policy part, you see the execution prevention, which is, let me say, the next-gen AV part. You see here malicious file detected, blocked that. This is policy enabled or not. Suspicious driver loaded. I don't go with it now in every single feature, but gives you just an idea how it looks like. You see here the exfiltration prevention. As you could see here, access to critical system information. So if an unknown process tries to access that, you can block that. The same is for, as an example, execute a program as no installer. So then you could also say, well, must be suspicious at least, block that please directly. And hidden processes, so processes running in the background doing some stuff which you should normally see on the desktop, which I didn't see, block that, and so on and so on. You can go really in detail and define for each of these settings what should happen, or you can of course leave it then to the default settings. That should be normally really more than good. We have here the ransomware protection. You see here this encryption attempt detected. So this is if an unknown process hits files, a lot of files in a short manner of time, and change the state of the file or the name or something else, then the system will define, okay, it must be a ransomware attack, and we block that, and so on. You see all these different parts here which you can enable or disable what should happen to the machine like that. You have a device control, which gives you the possibility to say if you use the audio or video device, as an example, detected, block it, or enabled it. Same with hub detect, the human interface, and all this, which you can say allow that or disallow that, or you can say here you only allow specifies application on the USB device, and so on. We have an application control part, which we come a little bit later to it, more let's say detail, and we have the extended detection part, which is when you use XDR and you connect it to email as an example, or for the Fortinet analyzer, that you also got information from a Fortinet analyzer, and then you can use this information as well to define this is an attack or is it suspicious or malicious. You have your exception manager here. where you can say, okay, which is accepted, which is allowed to run. Exclusion manager, which you can do by your own. You could say, hey, I need this process, for example, this is a good one, which maybe the system is meaning it's at least suspicious. Could be happen sometimes if you have self-written software which doing some strange things in the background. But you can do that, put that into exclusion manager to be sure that it will run. And we have application control manager here, which you can define applications to detect that and to allow to run that. And then we go into the threat hunting part, and here you define what kind of logs or what kind of information I like to see in my database here or in my dashboard. And as example, let me say you start here with the default. So you want to see files that are detected. You could also give me information as an example if a screen capture happens, if a process will be terminated or created. Process creation makes more sense. A process start, if depends a little bit. So I got all the information of every process we will start on the machine. So maybe I got overwhelmed by information. What could be interesting, as an example, on server side. So because normally they're running 24 hours and 7 days per week. But makes sense to see if somebody starts a process that I get this information. You can enable show me if a file created, show me if a file written or was a reader as well. But you see, you got a lot of information there. You can a lot of information enable. You can down to registry to see what's going on registry, and so on and so on. And of course, you can build your own entries here to say, okay, please, here as an example, I have enabled show me if a registry key is created, and so on and so on. So you define what kind of information, how many information you get back from the client to use this information then for threat hunting or for ILC hunting at the end of the day. Then you have collection exclusions. You also could say, hey, okay, I define to see that part that at the end of the day gives me too much information. And then you also could say, yeah, okay, don't show me as an example the default Windows system processes and so on and so on, just to predefine what kind of information do I like to see and which informations I'm 100% sure they are normal and don't have to see that, just to make it a little bit easier to read at the end of the day. And then we jump into the playbooks, which I mentioned before, is this automatization. So here you can define if something happens on the machine or what happens on the machine, then make this, this, and this. And you could see here, if the system found some malicious code, then you could say, okay, isolate the machine or move the device to a high security group. The same for suspicious or potentially unwanted programs, and so on and so on. Of course, you could say terminate the process, delete the file, and so on. So you can really define here what's going on the machine. And of course, you can create also your own here based on, you can define it based on groups. So you can do for every group different playbook as an example. It helps you to, yeah, let me say, makes your life a little bit easier, so you don't have to run behind every malicious setting, malicious finding, as an example, and just saying, hey, okay, delete this process, put the machine for some time into a high security group, and put it back, as an example. And the communication control, and this is the part which I mentioned before with virtual patching. You see here, you see an overview of all your installed applications here. In this case, we only see now this with the critical vulnerabilities. And then you can create, based on this information, some policies. As an example here, we have a policy created which says on server, I don't allow any policy, any high critical vulnerabilities on the machine. You see in detail which version is it from, as an example from the Firefox. You see here what kind of vulnerabilities are behind. You see the link to the CVE database to get more information about that. You see which policies are affected by that vulnerability. And of course, you see as well on how many machines is it installed, how often was it used, and so on and so on. So you got a lot of information on that, and based on this information, then you can really decide what should I do, or maybe in which policy I should put this. And of course, you can then use also advanced filter to say, okay, show me everything what's going on with the machine. Can say here now, show me only vulnerabilities is less or greater equal to, let me say, medium as an example. Then you see here, okay, all these machines are with some medium vulnerabilities on it. Gives you at least an overview what's going on your environment, and you can define that, what to do with that. And also you can enable then the virtual patching for that to give you a lot more security and reduce the attack surface for your environment. Important to know, you only see the information about applications which are installed in your environment. You only see applications which are somewhere in your environment installed. So if you see, as an example, you see the FortiClient endpoint management naming, that means, okay, somebody of your clients has a FortiClient installed. And maybe you are not a FortiClient customer, and you know, okay, there's something strange, which I should take an eye on it and define why this client, as an example, in my environment has FortiClient installed. Or maybe Chrome or whatever, or Firefox, and maybe you don't allow to use Firefox, and so on and so on. So you got a lot of information out of that, and based on this information, you can create some policies. And you see here isolation policy. Let me check this one here. I have here policy, okay. Vulnerability is greater than or equal to high, then I just say, okay, action is denied. I no longer allow this application. Important to know it doesn't mean that the application itself will never start again. The application is able to start, but we will block the vulnerable part of this application. It brings you maybe also in a situation that you say, okay, I need to use an older, I don't know, Firefox version because of some compatibility issues with an application. You could still use the old Firefox version, but all the vulnerable part will be blocked. Maybe that helps you to use still, or you can still use the old version of Firefox with this vulnerability, but the vulnerable part will be blocked, so you are no longer, I'm sure, to use that. You see also how many applications then are affected by that. You see here this Firefox, some OneDrive, Office, Chrome, and so on and so on. And before we go into the forensic part, let me go back to the dashboard and let's say, okay, show me what's going on this machine here. And you see, this is now, welcome to EDR. You got a lot of information, what is happening on the machine and why the machine comes, in this case, to inconclusive status. But the system also defined that must be malicious and blocked. You see the inconclusive part is here the dynamic code, which was created from the Firefox executable, which the system defines that must be malicious, blocked, but the system is not 100% sure about the code. Inconclusive means there are still some investigation in the background are running. The system defines at the end, okay, all this together must be malicious, but this one here, it's, yeah, let me say mostly malicious, but we need some more investigation for that. And this is a little bit the idea, or not a little bit, this is the idea behind EDR, that you really see in detail what happens. So you see there was a process created, another process created, da 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 da, and then Firefox creates a dynamic code which do something strange, and this is the moment which we defined, okay, no, we have to block that, that looks really bad, or it looks like a well-known malicious behavior. And you see that also in automated analysis, as an example, you see the memory addresses where it happens, and so on. You see the SHA numbers, you get all the information you need to define what's going on and why it happens. Of course, you could say here that is okay, that wasn't false positive, put this to the exception manager, or you also could say, no, looks a little bit strange. Should see more, a little bit more in detail, and then you can go here and say forensics. You see this in detail, what's going on. And then you also can go into open the threat hunting, and then you see what's go really in detail. So you see, okay, what happens when there was process creation from this DDoS daemon here. You can open that and you see all the details, which product was, which SHA was, which user, which pass. You can define it down to the next step and the other next step, and so on. So you see really in detail, in deep detail, what's going on, and that is what we mentioned with this threat hunting, that you really see in detail what's going on, and then you can decide. In this case, we know it is malicious. If it's suspicious, then you really can decide, no, that it's okay. I can make an exclusion for that, as an example. Or you really could say, no, this is something I don't like to have, or this is something which I know it's bad, and then you're able to block that. You see that here, the processes, which files are affected, and so on and so on. So you see all the information, what's going on the machine, which you need to know. And this is here the forensic part, and you see here the events as well. And see here, as an example, this is the classical ICOR, which is really okay, no, not a problem to detect, but you see here as well, the process was created, not a process, then the window Excel was created, user init, and so on, and then the malicious file detected. So that was a zip file, I unzipped it, and behind that was the ICOR, and then he detected and blocked it. That was, let me say, this was an easy part. But you could also use the threat hunting part to say, okay, as an example, I saw or I heard something in the world that there's an attack out there, which is an, I don't know, which a file affected, which called, sorry for that, in this case, maybe arrow. I can search, okay, show me all the clients in my environment which has this file arrow on it. And then I see, okay, I have this Windows 11 client, I have this CentOS client, and then you see not only, oh, there's the file, you also see if the file was created, as an example, then and then, from the user admin, from this and this process. It was written here from the Explorer exit. It is on this and this destination. Explorer exit was used in this and this version with this and this hash key. Where is this file now? Where's the path to it? And so on and so on. This is one of the, let me say, strongest part for EDR in general. So if you got the information from somewhere, somebody told you, hey, we know there is an attack with, there's maybe this and this website involved, or this and this IP address, or this and this URL, or this file name, or this hash key, or whatever. You just can go in here and put it in and say, okay, just show me about, you see here, everything what you like to see. This is that what the EDR at the end of the day means with this endpoint detection and response. So this is really the detection or the response part, that you can go in and say, okay, show me which of my clients are affected by this and this file, or this and this URL, or whatever. Then you really got in no time the complete view about your environment. You know, okay, of my, I don't know, 3,000 clients, these 150 clients are affected maybe by this and this attack, and then I have to take care about them. And you got this information more or less in real time, so because all this information are in the database on the system, so you don't have to ask the client first and say, hey, scan please the machine for that and give me this information back. No, all this information are in the database of EDR, and so if you look for something, you look into the database directly. That's why we are so fast, and you got this information in, let me say, more or less real time, and then you can react on that. So that was, let me say, an EDR in a nutshell, to just show you what we are doing there and to give you some information about that. Any questions so far? Expect from Herr Tischer.
Thank you. No questions.
Perfect. Cool. So
Okay.
then I would say thank you very much.
Thank you for presenting the whole stuff. And I think for some partners, it will be very interesting to see, yeah, what's the next level of endpoint protection and where to go and what's the future looks like and how many information you can get and gather about your network. So thanks a lot. And I would say, yeah, if you have anything, questions, don't hesitate to contact us. Martin will be available. We will grab him if there are any questions. And yeah, thanks a lot and have a nice day.
You too.
Thank you very much,
Thank you,
guys.
Martin. Thank you,
Bye-bye.
guys.
Thank you very
Bye.
much.